We've been listening for aliens for over 60 years. We've heard almost nothing. For decades, humanity has pointed its most sensitive instruments skyward, straining to catch even the faintest whisper from beyond our solar system. It's a profound gamble, the search for extraterrestrial intelligence, or SETI. And despite the popular image of flashing lights and dramatic encounters, the reality of SETI is far more patient, more painstaking, and infinitely more silent. This isn't about little green men in flying saucers. SETI is a serious scientific endeavor, born from the understanding that if intelligent life exists elsewhere, it might just be sending out signals, perhaps inadvertently, perhaps deliberately. The challenge: deciphering cosmic static from a coded message. The very idea gained traction in the mid-20th century. In 1959, physicists Giuseppe Cacconi and Philip Morrison published a landmark paper in Nature, suggesting that radio waves would be the ideal medium for interstellar communication. They even proposed a specific frequency, the 21-centimeter line of neutral hydrogen, a universal beacon. This paper ignited the modern SETI movement. Just a year later, in 1960, astronomer Frank Drake launched Project Ozma at the National Radio Astronomy Observatory in Green Bank, West Virginia. He used an 85-foot radio telescope to listen to two nearby stars, Tau Ceti and Epsilon Eridani, for about 200 hours. Drake heard nothing conclusive, but Project Ozma proved the concept was feasible. It also led him to formulate the famous Drake equation, a probabilistic argument for the number of communicative extraterrestrial civilizations in our galaxy. While highly speculative, it offered a framework for thinking about the problem. Then came the most tantalizing whisper. On August 15, 1977, Jerry Amon, a volunteer with Ohio State University's Big Ear Radio Telescope, was scanning printouts of data. He saw a sequence of characters, 6-5. It was an intense, narrowband radio signal lasting 72 seconds, exactly what a deliberate interstellar transmission might look like. Amon, astonished, circled the anomaly in red ink and wrote "Wow" next to it. The signal came from the direction of the constellation Sagittarius, near the globular cluster M55. It was 30 times louder than the background noise. For a fleeting moment, it felt like the universe had spoken. The "wow" signal remains the strongest candidate for an alien radio transmission ever detected. Despite repeated attempts, it has never been detected again. Its transient nature is one of its most perplexing aspects. Was it a one-off message, or just an unrepeatable terrestrial anomaly, a fleeting ghost in the machine? The "wow" signal underscored SETI's profound challenge, distinguishing a true extraterrestrial message from the immense ocean of cosmic noise and from our own terrestrial interference. It also highlighted the difficulty of verification. One signal isn't enough. Repeatability is key. After the initial excitement and subsequent mystery of "wow," SETI continued, often with limited funding. NASA ran its own SETI program for a few years in the 1970s and 80s, but political opposition, largely from Senator Richard Bryan, saw federal funding cut in 1993. This setback led to the rise of privately funded SETI efforts. The SETI Institute, founded in 1984, became a major player. They continued the search, developing sophisticated algorithms and using increasingly powerful telescopes like the Allen Telescope Array in California. The Allen Telescope Array, or ARDA, is a collection of 42 small radio dishes designed to simultaneously observe a wide range of frequencies. It's like having many ears listening at once, drastically increasing the chances of detecting a signal. Beyond radio waves, SETI has diversified. Optical SETI, for instance, looks for short, powerful pulses of light that could be deliberate laser communications. Imagine an alien civilization using a massive laser to send a message across the stars. There's also technosignatures, the broader search for any signs of technology. This could be anything from artificial structures orbiting distant stars, like the hypothetical Dyson spheres, to industrial pollution in exoplanet atmospheres. The data generated by these searches is staggering. Modern SETI is a big data problem, requiring immense computational power. Projects like SETI at home, which harnessed the idle computing power of millions of personal computers, showed the public's appetite for participation. But the silence persists. After decades of listening, of searching, of refining techniques, the universe remains largely quiet. This silence, in itself, is a profound piece of data. It forces us to confront the Fermi paradox. If intelligent life is common, where is everybody? The paradox has many proposed solutions. Perhaps advanced civilizations are rare. Perhaps they don't use radio or light in ways we'd recognize. Maybe they exist, but are too far away, or their signals are too weak to detect. Or perhaps, and this is a sobering thought, they self-destruct before they can reach us. The sheer scale of the cosmos is almost incomprehensible. Our galaxy alone contains hundreds of billions of stars, many with planets. The universe holds billions of galaxies. The odds, statistically, seem to favor life, and intelligent life, arising somewhere. Yet the lack of a definitive answer doesn't deter SETI researchers. For them, the search itself is meaningful. It's a testament to humanity's innate curiosity, our desire to understand our place in the universe. It pushes the boundaries of our technology and our understanding of physics. What if we do find something? The implications would be monumental. It would fundamentally alter our understanding of life, consciousness, and our own unique position. It would be the ultimate answer to the question, are we alone? The protocol for such a discovery is surprisingly simple. Verify, confirm, and then inform the world. There's no secret cabal. The intention is transparency. Any verified signal would be shared widely, subject to scientific scrutiny before public announcement. Today, SETI continues to evolve. New telescopes, like the Square Kilometre Array, promise unprecedented sensitivity. Machine learning and AI are being deployed to sift through the data, looking for patterns that human eyes might miss. The techniques become more sophisticated, the listening more patient. The wow signal remains a ghost, a compelling what-if, but it serves as a powerful reminder that the universe, in its vastness, might just hold the answers we seek. And somewhere, out there, perhaps another civilization is asking the very same questions, patiently listening. The quest for extraterrestrial intelligence is one of humanity's most profound scientific adventures, a testament to our enduring curiosity about the cosmos. It's a journey not just to find others, but to better understand ourselves. Explore the cosmic mysteries further with our next deep dive into the search for life on Mars.